We propose a technique that emulates the rubber-like exaggerations common in traditional character animation. Using our method, we can convert the realistic motion capture data, which can be seen on the left side, into cartoon-like motions on the right side. Converted motions are effectively exaggerated, and the figures have rubber-like limbs by allowing each link to be stretched or shrunk. To allow the character's body to be stretched or shrunk, we exaggerate the trajectory motion of each point. An example of the trajectory curve of the point is shown here as a red curve. We compute the local average curve, shown here in green. We can attain the exaggerated curve by blending two curves with an appropriate weight. By applying this technique to all joints, we can get exaggerated motions with stretched limbs. To keep the motion from stretching the length of the original link too far, we correct the position of each joint with a direction vector from the parent joint to its child joint iteratively. A link of excessively violated length is corrected to have an acceptable link length. Our key idea to convert a simply exaggerated motion into a rubber-like motion is the subdivision of a character's links and joints. We subdivide the link into small sublinks of equal lengths, and then create a new subjoint at the end of each sublink. We interpolated all positions of the original joints in each limb for each frame by curve interpolation, and defined the position of each subjoint at a point on the interpolated curve with the appropriate parameter. As a result, the character achieves the rubber-like body. To generate a follow-through effect from an exaggerated motion, we select the extreme poses of a given motion manually, and use the mass spring simulation from the start time of each extreme pose to the midpoint between two extreme poses. The simulated motions are then blended with the exaggeration motion. We can attain the final results comparable with the exaggerated motion using other methods. While other methods generate the exaggerated angle motion of each joint, our method generates spatially exaggerated trajectory motions of each joint by stretching links. Moreover, exaggerated motions using our method have rubber-like limbs, while it is hard to make such motions with other exaggeration methods. Here are examples with skinning meshes.